So this is number 1 of week 32 Thursday, and it says the value of the expression below can be altered by including parentheses. If we are allowed to place as many parentheses as we want, how many distinct values can be obtained for the expression? So here we can start by drawing some parentheses sets like this. Actually, I should probably use a different. And we can see that there are in total 6 total sets of parentheses. But we can see that this set, the red set of parentheses here, it doesn't really matter if we put it or not because by default it comes first. Therefore, we can just remove this. And now we have 5 more parentheses, 5 more sets. So the question conveniently placed all of these as prime numbers, which means that you can't have the same value for every set of parentheses. So for example, let's say that we only included the blue parentheses, these two, and the purple parentheses. So that means that over here, so we'd only have the blue parentheses and the purple parentheses. So basically like this. So then this would basically just be 2 over 3 divided by 5. And so just 2 over 15. And you just keep working 1 divided by 2 over 15 is just 15 over 2. Divide by 7, 15 over 14. And then, so just you end up with 15 divided by 14 times 11 times 13. Now, if we were to just include like the, let me see what's up here. If we just include the green parentheses, for example, so basically just these ones, then it would produce a whole different solution because just 1 divided by 2 divided by 3. 11 over 13, and then 1 divided by 2 divided by 3, and it create a whole different solution. Then that's why the question conveniently gave us prime numbers, so that they would provide us with different answers for no matter what set of parentheses we pick. Now, as you can see, there are 5 different types of parentheses. 1, 2, 3, 4, and 5. So therefore, we can either choose each of these to stay in the equation or out of the equation. Therefore, there are 2 choices. Like, let's say that because there are 2 choices for the blue one, either to stay in here, to be in the equation, or to not be in the equation. And 2 for this one, and so on by the same logic. Therefore, there are 2 to the 5, or 32 possible solutions for this. So also just keep in mind that the pair with 1, this doesn't count because it's by default already going to go first. So therefore, we don't have to include it. So in this question, it's basically the same thing. And all you're doing is just adding another set of parentheses over here. Therefore, it's just 32 times 2, which is 64. Which is also 2 to the 6th, but same thing. So the 2 answers are 32 and 64.